at the beginning when I start a new video. Okay, so when x is -4 minus 2 is -6, the absolute value is 6. But y, or f of x, is -6. So this point is not on the graph of f of x. It does not verify the equation. Therefore, it's not a point. It's a point somewhere here. Anywhere, doesn't matter. But not on the graph, because it does not verify the equation. Good. Moving on. Okay, so there are a few functions that we need to understand. And when you do the work, you'll see what I'm referring to. The simplest, or the simplest quadratic function. The simplest quadratic function is f of x equals x squared. And we need to remember the graph. It's a very simple graph, easy to remember. It looks like this. Like a little mug, like it holds water. So y equals x squared. So this is the simplest possible quadratic function. The simplest linear function. The basic, or the simplest linear function. It's also called the identity function. You'll see why. Because f of x, which is y equals x. Y equals x. Y is identical with x. The identity function. Very important function. Easy to remember. A straight line. It bisects the first and the third quadrants. It goes right through their middle. This is it. Y equals x. This is the identity function. Easy to remember. Good. The next one is the absolute value function. Easy to remember as well. F of x, the simplest one. As you notice, there is nothing there. They're completely clean. Just x squared, nothing else. Just x, nothing else. Just the absolute value of x, nothing else. This is also an easy function to remember. Look, this one you can remember it like a little mug. Not really, because it doesn't sit on anything. And this one is a v function. This is like a v. Bisects the first quadrant and the second quadrant into two equal parts. Y equals the absolute value of x. Okay. If you want to graph any of these with the graphing calculator, see, here's how we do this. You go to y equals, y equals clear. Okay, I'm going to put all these three functions. So x squared, we know the graphs. We know what to expect. Okay, the absolute value is, so x, and then the absolute value, you will have to go to math and scroll to the right to numbers to get the ABS. X. Now, let me explain a few other things here. When you click on zoom, you see number 6. Number 6 is Z standard. The Z standard means the standard viewing window. Standard viewing window. What does it mean, the standard viewing window? In the graphing calculator, of course. It means -10 to the left edge of the window, +10 to the right edge of the viewing window, -10 at the bottom, and +10 at the top. In other words, we only see for x between -10 and 10, and for y between -10 and 10. That's what the standard viewing window represents. Now let's make a decision. Is this good enough for this? Yes. Is this good enough for this? Yes. Is this good enough for this? Yes. Otherwise, I will have to adjust the viewing window. How do I adjust if I need to? I will not adjust it now. I will use Zoom 6. But if you need to adjust it, you click on Window, X minimum, X maximum, the scale. The scale means the tick, how far apart the tick is. I mean, on the x-axis and the y-axis. Okay? And that is the scale. And then y minimum, y maximum, and the scale on the y-axis. But for now, we don't need to adjust the viewing window because the standard viewing window works fine for all three. Now, please pay attention because they will go very fast. So purple, red, and black. Okay? Zoom 6. Careful. 1, 2, 3. So this is the x squared. This is the identity. And this is the absolute value. Any questions on these three functions? Okay. The system will ask you to graph those so you know what to expect. Of course, if I want to graph negative x squared, how will I graph negative x squared? So when you get to the homework, please mark down all the problems that you need clarification on. So this is x squared, but the negative x squared will look like this, right? Y equals negative x squared, because we are multiplying by -1. Another function that I would like to add here to the list is the square root function. The basic one, the simplest possible one, is the square root of x. We haven't talked about it yet. We will. This is happening now in this module. But I'd like us to remember the graph. And I will have them on paper and look at them every now and then and refresh our memory on how the x squared looks like, how the identity function looks like, how the absolute value looks like. And here is the square root of x. It's not a straight line. So this is y equals the square root of x. Okay, I'd like us to, any questions? Okay, we're going to open the practice in a moment, but I just want to discuss something on a graph. So let's suppose we're going to look at a graph like this. When we see arrows, like this one going up and like this one going down, it means that the graph goes on forever. Goes on forever. Few questions here. The first question that we are very, very interested in is finding domain, finding range, x and y intercepts. So let's start with the x and y intercepts. We know from a long time ago that the equation of the x-axis is y equals 0. We know from a long time ago when we graphed very simple functions, linear functions, that the equation of the y-axis is x equals 0. So then where are the x-intercepts? And by the way, the x-intercepts are also called zeros of f of x, or roots of f of x. So if somebody asks you, find the x-intercepts or find the zeros of f of x, in other words, where f of x is 0, or find the roots of such and such equation, meaning f of x equals 0, that's what we are asked to do. So we will determine here this, this, and this. This function happens to have 3 x-intercepts. What about the y-intercept? Here's the y-intercept. 3 x-intercepts and 1 y-intercept. How do I find for this function the domain and range? What does domain mean again? The values of x for which the function exists. Exists for everything because of the arrows. It will go on forever. For any x value, I will find the y value. And the same thing for the range. How do I find the range? The range is determined on the y-axis from the lowest y value. We'll have examples in a moment. From the lowest y value to the highest y value. The domain is measured on the x-axis from the leftmost point of the graph till the rightmost point of the graph. So we have an idea what this means. I'm just going to open the practice for 7.3 and let's work on some problems here. We want to identify domain and range and x and y intercepts. Okay, so because I opened on this problem, let's take a look. So here they want the domain and range, but not from a graph, but from representations of sets. So 5, -18. It's not here. It's here. And it's not here. So obviously we are looking at B. So write the relation as a map. Okay, this is it. So 5, -18, -4, -4, -9, 0, -4 again 4, and 5 again 18. So this is the map. Identify the domain. Very simple. 5, -4, -9. But I have to write them in the correct order. Ascending order. -9, -4, 5. That's the domain. So here's how we enter it, with braces. And we will enter it as -9, comma, -4, comma, 5. This is the domain of this relation. What about the range? Again, in the correct order. -18, -4, 0, 4, 18. And that is the range. Good. I just want us to look at the graph. Okay. Identify the domain and range of this relation. Okay. Let's also do this one. So, from left to right, I see -4. I'm going to write -4 is in the domain. I see -2. Okay, -2, comma. I see 0. Okay, comma. I see 2. Yes, and I also see 5. So the domain consists of all possible, this is not an interval notation. Why not? Because the points are not connected. They are standalone. And the function exists only, the relation exists only at those points. If you ask me what is the relation value at -3, I'll say, I'm sorry, there isn't one. At -3, there is no value. But if you ask me what is at -4, I'll say, okay, at -4 is 4. If you ask me what about -1, I'll say, sorry, there is nothing at -1. There is nothing at -1. But if you ask me at -2, I'll say, yes, it's -1. So the domain is only -4, comma, -2, comma, 0, comma, 2, comma, 5. And that's it. Now it's going to ask,
Question.
yes, please.
Okay, so if it's two dots on the same line, that is automatically 0?
You mean here, these two?
No, like the 4 and the 2. This one. Yeah, that one.
This one and this one?
Yes.
So at x equals 0, the relation is 4, and at 0 is -3. Very good question. Let me explain that. When x is 0, we have 4, and we also have -2. So x equals 0 corresponds to 2 y values. Is that okay?
Yeah.
Okay. Good. So now the range. To identify the range, notice that to identify the domain, we started from left and we went slowly but surely to the right. Now we want to find the range. The range is measured on the y-axis. So we start from the bottom and we go up, 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 -3. Can anyone give us the next y value where we have points?
4.
The next y value, we have to go from the bottom to the top. We identified -3. What is the next in line? Next in line going up.
-1.
-1. Everyone sees the -1 is right here. Yes or no? The next one is indeed 4. And the last one is
5.
indeed. Because the points are not connected, we cannot use the interval notation. And the final check. Good. Perfect. Now here, we want the same thing. We want to determine the domain and the range. What would you say about the domain? In interval notation, and we'll write it together. So the graph is something like this. Not exactly, but this is f of x. So we want to find the domain and we want to find the range. So the domain means, first of all, we measure it on the x-axis, since it goes on forever. The domain exists from -infinity to infinity. Although you can say, oh, I don't know. Yes, because of the arrows, the domain is written as -infinity to infinity. We studied the interval notation last time. The range, though, starts from the lowest y value till the highest y value. And we cannot read it from my graph. So let's read it from the graph here. So we do enter negative infinity, comma, infinity, okay? And that's the domain. And now we're going to enter the range. Can anyone identify the range? From the lowest y value till the highest y value.
Bracket -2 to infinity.
And excellent. Bracket -2, comma, infinity. With parentheses. And that's it. That is indeed the range. Okay, I want to find a different problem in which we will determine the x and y intercepts. These are all variations. Is this a function or a relation? Is this a function or a relation? By the vertical line test, the graph in this figure is or is not a function.
Yes, it's a function.
By the vertical line test,
No.
no, because we found an x value. It's sufficient to find an x value. For x equals 10, I will read 2 y values. Good. Same thing here, not a function. By the vertical line test, not a function. By the vertical line test, yes, I want to work on this. Okay. So here we're asked again to find the domain and the range. I will find an example with x and y intercepts in a minute. But right now, we want to find the domain of this function. From the leftmost point till the rightmost point on the x-axis. From the leftmost point to the rightmost point on the x-axis.